So now we'll move on to integrations of the expression ax plus b to the power of n. In your textbook, you'll find that this formula and obviously you can use this very quickly to do it mentally. You'll be able to do it mentally very fast. But I would like to explain where it comes from and why it must be this linear form. And let's think about something like, say, dy dx equals six 2x plus 5 to the power of 9. And we need to find we don't need, I'm not going to do let's say we're just trying to integrate this. What I would do is we could have expanded that, but we're not going to. So instead we're going to do a u substitution. This is going to look familiar as being a bit like chain rule. And then so that tells us that du dx will be 2. And then we could have written this as 6u to the power of 9 dx. But this isn't exactly very helpful because dx is x is different to u. Now we have an expression in terms of u, not dx. So we must rearrange this to get dx equals du over 2. And so we change this to du, and that's over 2. So that becomes 3u to the power of 9 du. And now we can apply power rule, reverse power rule, and then replace this with the original one here. And so that 1 over a bracket n plus 1, that's, we've multiplied our integral has got a 6 there, so we'll remove that 6 away, and then that would leave us with just 1 over 20, because 3 over 10 is 6 over 20. It's 3 over 10 is 6 over 20, so 20, that is equal to that 2, brackets, 9 plus 1, which is a n plus 1. And this comes from the fact that a comes from the fact that we've differentiated that and rearranged it to get dx equals du over 2. And that n plus 1 is just part of dividing as part of the power rule when we divide by the new power. And the reason why this will only work with linear functions is if we try to do a u sub with an x squared, equal x squared plus 5, du dx equals 2x, dx equals du over 2x, and then we did 6u to the power of 9 over 2x du, then now suddenly we've got two different variables and we can't do the integral. So that's why it has to be a linear function in the bracket. And we can actually use that. There is a question type that we can use to do that. For example, it might tell you to differentiate x squared plus 2, 4. So then you do your chain rule. du dx equals 2x, and then u4 dy du equals 4u3, so then dy dx equals 4 bracket x squared plus 2 to the power of 3 times 2x, so that makes it 8x, x squared plus 2, 3. And then it might tell you, okay, you've done that, now integrate x squared plus 2 bracket 3. And we can see that when we differentiated this, we got something that is now 8 times this. So what we will do is we say that the integral of x squared plus 2, 3 dx is equal to 1/8 of x squared plus 2 to the power of 4. Plus c, of course.